All right, so this is Unit 1, Lesson 1, Explore, or page 2. We're supposed to be able to solve 1 and 2 linear equations, 1 and 2 step linear equations by using inverse operations. So we're supposed to be learning how to distribute. Okay. Before, if you had 3 and then 2 plus 1 in here, order of operations says do this first, and that would give you 3 times 3 equals 6. Well, now we're going to have items in the parentheses that you can't add together first. We don't know what x is, so I can't multiply 2 times x to subtract 7 from it, so I can't do that step. So when you distribute, you're distributing because that's going to end up being your first step. So you're going to see on the next pages, the first step for processing equations is distribution, combine like terms, move, and isolate. So I call it Dear Charles moves in instead of please excuse my dear Aunt Sally. The PEMDAS is for your expressions. PEMDAS. Okay, when you have an equation, you're going to work on one side of the equation doing your PEMDAS, and then you're going to work on the other side of the equation doing the PEMDAS, and then when you're ready to move across, move, and isolate, you're going to be working across to organize things across the equal sign. So right now, we're just going to learn how to distribute. And at the bottom, we're going to learn how to combine like terms. Okay, that's what we're going to do on each side of the equations. So let's practice one side at a time. So even though this in the parentheses, I'm supposed to do something here first, I can't do anything here because these are not like terms. We're going to talk about like terms right there. So let's learn how to distribute. The 4 times the 2 is 8x. 4 times the negative 7 is negative 28. And I'm done because these are not like terms. What I have here is a variable term. And this right here is a constant term. Kind of talks about it up here. All variable terms have a numerical coefficient. That is, let's see, right here is a numerical coefficient. That's the number in front of the variable. If you just have an x sitting there all by itself, it does have a 1 there. It has a 1 up here. It has a 1 underneath here. There's a lot of ones you don't see. We're just going to talk about this one as being, the one in front, as being a numerical coefficient. So this times this is negative 35x. This times, so negative 7 times a negative 6 is going to give you a positive 42. And that's done. There's nothing else to do for that one. This one, if you want to add a 1 here, this is negative 1 times 4 is negative 4x. Negative 1 times a negative 5 is a positive 5y. Negative 1 times a positive 6 is a negative 6. And then we take a quick glance. These are not like terms because it says it has to be variables and their exponents have to be the same. So x and y are not the same, so they're not like terms. So you can't add them together when you're combining terms. Okay, that's the final answer. This is negative 2 times negative 3 is a positive 6. This one is a positive 8. Okay, that's it for distributing. Then to combine like terms, it says when simplifying an expression, you can only add and subtract like terms. Okay, so here's a 2x and a 3x. They're like terms. They're both positive, so now you have 5x minus 2. That's not a like term, and then we leave it there. Okay. There's no other variable terms, so just r, and then 10 plus a negative 9, or negative 9 plus 10, is going to leave you with a positive 1. Then 1x plus 1x plus 1x is 3x's plus 3. Okay. And then 2 minus 1x minus 3x minus 3 plus 4x. So lots of stuff going on there. There's an x term, there's an x term, and there's an x term. So those are all like terms. So I have a negative 1x. As a habit, I think I just put the ones in there because they are in there, and sometimes it helps. Negative 1x plus a negative 3x is a negative 4x. Oh, plus a positive 4x. So let me write that down. That is negative 4x plus a positive 4x, and then I've got this one and this one. So that is a minus 1. But these cancel each other out. It happens sometimes. So your final answer is a negative 1. And I lost all my x's because I didn't have any more. All right. A negative 1x plus an x is a 0. You lose your x. Okay. Let's see. 5 plus 3 times 2 is 6. 3 times negative 4 is negative 12. So I distributed. Then I'm going to combine like terms. 6x minus 7. That's my final answer. So look at these. I got a final answer of a negative 1. I got a final answer that's got 2 terms. I got a final answer up here that had 3 terms. When you're working with expressions, you can have that. Okay. All right, 3x, I don't touch that because I need to go ahead and distribute this here. That turns into a negative 8 and a positive 10. Notice I'm not taking the time to write 3x plus a negative 8x. Just write it this way because then I'm going to combine both terms here. It is negative 8. It is a positive 3. Positive 3x minus 8x is a negative 5x plus 10. Final answer. Okay. All right, distribute. This is 10x. Distribute minus 16. And then I'm going to throw a plus in there because then this is this times this. So if you want to, you can do 24x plus, minus, or I could put a plus 18. Didn't have to do all that, but I could have just wrote 10x minus 16 minus 24x minus 18. Let's just do that. Don't need all these extra parentheses here, okay? Like terms, including the negative in front. This is going to turn into negative 14x. And I'm going to add these two together. I believe that's correct. 8 plus 6, 14 plus... Yeah, that was it. All right, this one is 12x. This one is negative 32. Plus, well, let's just go with, it is a negative. Woo. Negative 1 times a positive 2 is a negative 2x. A negative 1 times a negative is a positive 7. Like terms, 12 minus 2 is 10. And negative 32, positive 7, negative 25. Okay. All right, I've got an x here and an x here. Sometimes you have to just go find them. Okay, so I have a positive 4x minus 1x is 3x. Then I've got a 4y. And then I have a constant term here and here. So I need to combine those. That's going to be, what, a positive 2? And I take a quick look, and these are all different and not like terms, so that is my final answer. All right, page 3. Dear Charles moves in. Distribute and remove parentheses. Then combine like terms on each side. So we're distributing, something here. equals something else over here. So we need to just handle that distribution by itself. We also need to handle any combining like terms by themselves before we start moving across the equation or across the equal sign, okay? When solving a one-step or two-step equations or more, there are rules to follow, rules of order to follow. So just like PEMDAS, there's a good mnemonic above to remember the required order. Just like PEMDAS, each equation may or may not involve all of the possible steps. So sometimes we don't have parentheses, sometimes we don't have exponents. But that's still, if we had them, that would be the order. So we don't always have something to distribute. We don't always have something to combine. But if we did, we would have to do those first. Okay? So the move and the isolate step involve one-step problems, and the general rule is to do the opposite. Okay, so we'll talk about that. It says move variable term to one side of the equation and the constant term to the other. That's kind of the general way to do that. Isolate the variable. So if we have, let's say there's my variable term. So we want to move variable terms to one side and get, the constant terms on the other side. That would be our goal. And then we're going to be isolating our variable by getting rid of what's next to it. So we're going to work on that. All right. So let's look at these examples. X plus 7 equals negative 5. There's a variable x on the left side of the equation, and it's added to a positive 7. Okay? There's nothing to distribute. There is no like terms to combine, so we're going right to the move step. All right? On the other page, we did distribution and combine like terms. Now we're going to do the move. So there's a negative 5 on the other. 7 and 5, negative 5 are constants terms. They belong together. We want to get them on side so we can combine them. Okay? So there's a special way to move them across the equal sign. The expression is to add its opposite. Okay? So if you are moving, what are we moving? We're moving the 7, right? Because our final answer is going to look like what? We want x on one side all alone and a constant term over here. So I know what x would stand for. So what needs to be moved is this 7 right here. And it needs to be moved over to where the other constant term is. All right? We move by adding its opposite to both sides. So here we are here. This is the x. There's the 7. Doesn't matter about the order, but we're going to go ahead and add a negative 7 to both sides. When we do that, this makes a 0. So you're left with your x, and then you combine like terms to get to your negative 12. Okay? That would be the horizontal way to do it. The vertical way, some people are I prefer vertical. You'll see me do it vertical on the board. This getting rid of the 7. So we want to subtract 7 from both sides. I like to do it this way because this makes a 0, right? X plus 0. We don't have to actually... Whoa. Let me do that again. We don't have to actually write the 0 in. So x plus 7 equals negative 5. Add its opposite. Oops. Hang on. X plus 7 equals negative 5. Add its opposite to both sides. X is going to equal negative 12. Okay? This is the horizontal, that's the vertical way. All right, what if x was on the other side? I still want to get this 9 out of the way and put it over there. Because remember, we're heading for an x alone on one side. So the problem is the 9. So we want to... remove the 9 from both sides. Okay? The 7 and the 9 are consonants, so we want them together so we can add them. So move the 9 to the other side by adding its opposite to both sides. So 7 equals x plus 9. You add a negative 9 to both sides. and you get, what, negative 2 equals x. Sorry for shoving it in there. And this one here, we have pretty much the same thing. We have a negative 5 that is in the way. I wanted to say x on one side with nothing else, so the negative 5 is the problem. So x minus 5 equals 4. We need to add its opposite to both sides to get x equals 9. All right? And now, remember, every one of these can be checked. If I say that x equals 9, that means I could substitute the 9 back in for the x. And that side of the equation better equal that side of the equation. Okay, 9 minus 5 is 4. So whatever I get for x, I should be able to plug back in. So back up here, if I say x is supposed to be a negative 2, let's check. 7 equals negative 2 plus 9. 7 equals 7. Okay? If I say x equals negative 12, I'm saying negative 12 plus 7 is going to equal a negative 5. And it does. Okay? So they're checkable. So let's try these. All right. We want the x to be there. It's the only x. There's a constant. There's a constant. So we want to move this guy that way. All right? So we move things by adding its opposite to both. And what we do to one side, we do to the other side. So x equals 4. Let me get my answer key out so I'm not messing any of that up. Okay, let's see. What is the problem here? This has to go. We need the x alone on one side. So we're going to add its opposite. And whatever we do to one side, we do the other side. And it bothers some people to have it backwards, but that's the same as that. I don't care which way I get it. I understand it. And let's see, this one, the 8's the problem, right? We want to get the x alone. We want to get the constant with the other constant. Whatever we do to one side, we do to the other side. And we get 13. Okay. That's the move part. So let's do the isolate part. Okay. It says isolate the variable in an equation, multiply or divide both sides by its numerical coefficient. This will result in the variable being alone on one side and the constant being on the other side. The value that has the... Okay, so that's a long way to say the x is going to end up on one side, the constant or the number is going to end up on the other side, and that's going to be what the variable stands for. So x equals 2, then you're going to say that 2 is what the variable stands for, okay? When a variable is being multiplied by a number, divide it to isolate it. When the variable is being divided, you need to multiply to isolate it. So that's the verbiage for that. Let's practice what they're saying. So if I have 4x equals 20, okay, the variable is on the left side. This is a variable term, right? Notice there's no distribution. There's no like terms. There's an equal sign in between these. There's nothing else to do. There's but get x alone. Okay? So to get x alone in this case, we're going to divide by 4. Because 4 divided by 4 is what? 4 divided by 4 is 1. That gets me my x. Okay? Whatever I do to one side, I do to the other side. That gets me my 5. Okay, you can always check 4 times 5 equals 20. Yay. All right, equals one side to the other. All right, and that move isolates your x. Okay, so if you have negative 5x equals 30, there's my variable term. There's the only x that I have. I need to get this numerical coefficient out of the way. So I do that. Notice that, talk to yourself. This is negative 5 times x. So it's times x. I'm not adding or subtracting anything. I am dividing by same. Okay? So when you're moving, you're adding opposite. When you're isolating, you're dividing or multiplying. I'll show you a different example in a minute. Oops. Dividing by same. And opposite, I mean sign. same sign. Okay, so when we're moving, remember we use the opposite. So removing a -3, we want to add 3 to both sides. Well, if you're isolating, you're dividing by the same sign. So if it's a +4, I want to divide by a +4. If it's a -5, I want to divide by a -5. And whatever I do to one side, I do the other side. So that's going to equal what? -6. And you can always put that in there. -5 times -6 has to be 30. So we're good. Okay. This one's a little weird. Let's say they give you this scary looking thing. This is where the multiplication comes in, because you really don't want to draw a big line here. What in the world are you going to divide by? It's going to be a little weird. So don't go there with that. Remember that when it looks like this, the easiest thing to do would be to multiply this by 5. Because if you multiply it by 5, you'll get 5x divided by 5. So the 5's will go away. And that's going to give you your x. Okay, you'll get 5x over 1 times 5 is 5. Reduce that. Right? Divide the top by 5 and the bottom by 5. You're going to get an x over 1, or x. Okay? So whatever you do to one side, you have to do the other. So if I multiply this side by 5, I multiply that side by 5. So that's a -15. So that's where multiplication comes in. Most of the time, you're going to be dividing by what's next to the x. Sometimes, if you're given a fraction, you want to multiply what's on the bottom of the fraction. Okay? Let's see. Down here, we have what? We have x over a -7 equals -2. I've got a fraction. I want to multiply to isolate my variable. Same sign. If I multiply it by a positive, I'm going to get a -1x, and I don't want to do that. I want a +1x. So I need to multiply by the same sign, and whatever I do to one side, I do the other side. So x is going to equal negative times a negative is a positive. And you can always check. Let's see, 14 over -7. Reduce that, right? 7 goes into that 2 times. And it would be -2, which is what we had. Okay? So let's do these down here. There's no distribution. There's no combined like terms. It's just I need to isolate my x. Divide by same. Divide by same. Whatever I do to one side, I do the other side. -12 divided by -6 is a 2. Okay? -6 times 2 equals a -12. So we're good. Let's see. This one here would be, look, my y is on this side. There's my variable. I got to focus in on that. What's next to it is a 7. To get rid of it, I need to divide it by a 7. What I do to one side, I do the other side. That makes that a y. And I don't think I can reduce that. And I'm done. It's okay if you have a fraction left. All right, this one, can I just lop off the negative and just make it disappear? No. What's in front of that? That is a -1z equals 12. So let's get rid of that the same way we get rid of anything else, because I want a +1z. This, what is this? 12 divided by -1 is a -12. Okay? So what we're saying is a -12 equals 12, and that is true, right? Okay. All right, this last one doesn't look like one we've been doing. So technically, I said you're supposed to isolate my x by dividing by what's next to it. So it's going to write something this kind of like that, which is very ugly. But that would make that go away. But what do you do with all this stuff here? So that's where this comes in. I recommend that you do this, and instead of dividing it, we're going to multiply it and flip that one. So you're going to get a -18 over 10, which apparently I could have reduced. Take the 2 out, the 3 out. So that would be a -9 over 5. Okay, get used to getting an improper fraction. It's okay. Some people like to clear their fractions if you're used to, so don't watch if you don't know what I'm talking about. But some people will sit here and go, you know what, the LCD is 6, so they're going to just multiply each side by 6 to start with. That makes it 5x equals -9, and then they divide by 5, and that gives you x equals that. Okay, so either way, they kind of do it in a couple of steps. This way works too, so either one of those. And I think that's it. Yes. Practice will be next.